this one here is geometric growth. And geometric growth means we are multiplying or we are dividing. In other words, when we say divide, we're multiplying by a half or a third or anything like that. Okay, but generally it's a times. So we're timesing it to get to the next number. So we've still got a recurrence relation. We can see our recurrence relation here. Remember, recurrence relation must have a v of 0. In this case, it's number 1. And then we'll have the n plus 1, which equals 3v of n. So this is multiplying, as we can see, by 3. And this is what happens. Before it was linear, can you see that this one is going to give us a curve, okay? Because this is a growth. So that's what this one is. It's a growth, and it gives us a curve. While the previous one, the linear one, gave us just a straight line like that. I'll just clear this. Of course, this is what I said, if we're multiplying by, or dividing by a number smaller than 1, in other words, multiplying by half or anything, even though we might have a starting value of 8, we're getting a decay. And again, it's a curve. So this part here is the decay. All right, so let's have a look. Clear this one here. Again, there's all these rules. We're going to go through these rules. We're going to make you understand how to get these rules when I can. So yeah, you can highlight these. You can do whatever. You might use them. You might not. If you listen to what I've said and you understand what I've said, you will be able to write these rules properly without following any of this. Okay, so example 1 says the following recurrence relation can be used to model a compound interest investment of $2,000. There's our start, $2,000, paying interest at the rate of 7.5% per annum. Okay, now this is an interest investment, so of course it's going up. So how do we get this 1.075? Because we already know how to get this v of 0. We can see it, $2,000, it's not a problem. But how do we get this 1.075? Well, I'm going to work it out on the side over here. Okay, so we put in $2,000. That's 100% of our money at the moment. But our money is going to increase because it's in investment and they're giving us interest, so it's going to increase by 7.5%. Okay, 1%, or 100 divided by 100, so that's just 1 because that's what percentage means, divided by 100, plus 7.5 divided by 100. Now 7.5 divided by 100 is 0.075. Add it together, you get 1.075. And that's how we get that number there. Any questions on that one? Now that we know this recurrence relation, part A says, use it to find the value of the investment after 1, 2, or 3 years. So, okay, n equals to 1. We're going to put, we're finding v of 1 year. So this is going to be 1.075 times the 2,000. I better work that out because I don't have it on my calculator. So let me just do this. Okay, times 1.075, I get 2150. Now we want the second one, so v of 2. V of 2 will be 1.075 times v of 1. Okay, 1.075 times 2,150. Okay, so I'll times that by 1.075, and that equals $2,311.25. Now I've got to do v of 3. V of 3 will equal 1.075 times 2311.25. Just going to rub that out so I can actually write it a bit better. V of 3 equals 1.075 times my V of 2, which is 1.075 times 2311.25, and this equals times on my calculator 2484, and I'm going to write the whole thing 0.59375. Now, of course, we're talking about money here, so we can't have that many decimal places. So really, this one here is $2,484, and it has to be 59 cents because we've got to round properly. Don't round to the 60 or the 55 cents. It's not, you know, where we go in and buy something at the shop and there's no 1 cent and 2 cents. When we're talking about banks, we include every cent. So 51, 52, 53, all the way through. So any questions with part A? Okay. Part B says determine the value of the investment when it first exceeds 2,500. Okay, well, we can do this a number of different ways. We can do it with solve, okay, or, well, that's the way I'm going to do it here. We can just keep going because we know that the next one will be it anyway. So if I times this number here for V3 times 1.075, we should know. So V of 4 will equal 1.075 times 2484.59. And when I do that on my calculator, times that by 1.075, it is $2,670.94 when I round it correctly. So really, I've already passed that amount. So when is it past that amount? Well, that was the third year. This is the fourth year. So the fourth year. Any questions how I did that one? I'll just give you a bit of time just to write anything down. And I'll clear it. Remember, I'm only going to do this one exercise today, so you guys have time to do that test. Can someone please let Anastasia know? She's told me that she wasn't going to be here today because she's got her other class. So if someone can please text her and say, look, can you do the exam 2, 2019 exam 2, the first part of the core, just in 20 minutes. And then we'll just go through any questions that you guys couldn't do. Make sure that you mark it yourself, and the ones that you couldn't finish in time, just go through before you check the answers, just go through it and make sure it's right. You know, you get them all done. Okay, let me clear this. Part C. All right, part C there's write down the recurrence relation if $1,500 was invested at a compound interest of 6% per annum. Okay, well, we know our V of 0. There it is there. That's our V of 0. Okay, beautiful. Let's get, and this is worth, of course, 100% already, $1,500. But we're investing it. That means it's going to increase. And it's going to increase by 6%. Okay, so divide this by 100. I'll do the whole steps here. Plus 6 divided by 100. It's going to give me 1 plus 0.06. So 1.06 is that rate that we're putting in. So now we're going to write our recurrence relation over here. Okay, so the recurrence relation, V of 0, $1,500. V of n plus 1 will equal 1.06 times our Vn. And there's our recurrence relation. Any questions how we did that one? Okay, I'll give you a little bit of time to clear this one. There is a couple of people that still haven't responded to me whether I can share these videos with the other students or the other teachers, and if they want to, they can share them with their class. If you can please respond, do so that I can do that with them. They already have my other videos, but it's always good to do this. And I might even ask you guys, and if there's only one person that says no, that is a no, if I can put them up on my YouTube channel as well. Okay, so I'm just going to clear this now. Example 2. Compound interest with different compounding periods. Okay, well, let's have a look at this. It says Brian borrows $5,000 from a bank. Of course, that $5,000 is the V of 0. So let's write that down. I'll just write it there. We'll write it down better later. Now, he's borrowing money. So when you borrow money from the bank does charge you interest. Okay, and it's added onto it, and you still need to pay off not only your loan, which is $5,000 here, but the interest as well. So we've got to be careful here that R is going to go up, that interest rate. So he'll pay interest about 4.5% per annum. Let V and be the value of the loan after n compounding periods. Write down the recurrence relation to model this. Okay, so we're talking about yearly here, and this is per annum, which means yearly. Okay, fantastic. So I'm going to write my R's right over here down this side. Okay, the $5,000. That's how much they give him. He's got to pay all that back, 100% back. Plus, in this case, he's getting charged 4.5% per annum every year, and they want it yearly here. Okay, so he's getting charged 4.5%. 4.5%. So this will be 1 plus 4.5 divided by 100, which equals 1 plus 0.0. 1 plus, I'll just write it as final, 1.045. Okay, so 4.5 divided by 100 will give me 0.045 plus the 1 will give me 1.045. Any questions there? Okay, so here we're going to write the recurrence relations. V of 0, in this case, $5,000. That will not change. Our V of n plus 1 equal 1.045 times V of n. Any questions on that one there? Okay. I'm going to squash a little bit, try and squash the part B down here. So this one is quarterly. So again, the R is still 100%. He borrows for $5,000. He's got to pay the 100% back. Plus, now this is 4.5% per year, per annum. That's what it means, per annum. But we want it every quarter. So how many quarters are there in 1 year? Well, there's 4 quarters in anything. So this is still going to be 100% plus 4.5 divided by 4, because that's how many quarters there are. It's still a percentage, and this is going to be per quarter now. Okay, so it's not an interest rate for the year, it's per quarter. Any questions on that one? If they want us to do it as a monthly, then we would be dividing this interest rate of 4.5 by 12, because there's 12 months in a year. Any questions about that? Okay, so this is going to give me 1 plus 4.5 divided by 4 is 1.125% per quarter. Okay, I've changed this. I've divided the 100 already by the 100. That's how I got the 1. Now 1.125% is 1 plus 1.125. Okay, just divided by 100. I'm going to try and squash it in, and I'll write my answer up here. So 1.125, divide that by the 100 because of the percentage, plus my 1, gives me an answer of 1.01125. Any questions there? You don't have to show all that working out. You can do it all in your calculator and just write down that answer. But until you get used to it, make sure you write it down. You can miss steps as well. So V of 0 here is 5,000. My V of n plus 1 equals, that's what we got, 1.01125 times V of n. Any questions on that one? Okay, I'll give you a little bit of time to work it out. If you want me to say anything about this section again, please ask me. Okay, let's continue. Oh, there you go, part C was monthly. So we still got our $5,000. That's not a problem. And our interest rate was 4.5% per annum. We've got our 100% that we have to add on, being the original. And V of 0 was $5,000. That has not changed. Okay, let's find our R this time. So we're going to have, we want it monthly. So 100% plus 4.5% divided by 12 months in a year. Per month this time it's going to be. So when I do that, and I'm going to do the whole thing on my calculator, 4.5 divided by 12. So this gives me 100% plus 0.375% per month. Now I've got to divide them all by 100. So that divided by 100 plus 0.375 375 divided by 100, which gives me 1.00375. Any questions there? Okay, so I'll write my rule. V of n plus 1, I can't write it beside it, we won't have enough room, that's why I'm writing it underneath, equals 1.00375 times V of n. Any questions? Okay, let's give you a little bit of time to write that down. Again, if this section, you need more of an explanation, please do so. I'm trying to write everything down, but I know that sometimes I run out of room. Okay, I'll clear it. Okay, reducing balance. Again, there's all these rules. Okay, let's go straight into the example. You can see that if it's reducing, remember it's going to be less than 1, not bigger than 1. Okay, so example 3. The following recurrence relation can be used to model the value of office furniture with a purchase price of $6,900. So there's our V of 0. Depreciating at a reducing balance rate of 7% per annum. So this one is depreciation. And even though they've given us the recurrence relation, I'm going to show you how to get this one. So they buy this office furniture, $6,900, that is worth 100% of the money. But it's depreciating, so minus. And how much is it going down? 7% every year. Okay, so 100% minus 7% gives me 93%. Now 93 as a decimal, 93 divided by 100, that's what the percentage means, gives me 0.93. So that's how they got the 0.93. Any questions about that one? Okay, so before we're adding because we're investing money and that money was making more money for us. Here, we're buying something and it's reducing because it's depreciating. And that's how we're getting a different ones, less than 1. So let's do part A. Use the recurrence relation to work out what it's worth at 1, 2, and 3 years. Okay, so we know this V of 1 equals 0.93 times $6,900, the original amount. Now we're going to do it differently this time. So everyone get out your calculator. And in your calculator page, put in V of 0, so $6,900, and press enter. So we're going to store that in there. And now we're just going to press times 0.93 and press enter, and it gives you the first answer, $6,417. Now I just want you to press enter again and it will give us the second answer because we've already stored it in there using that rule. So when I press enter again, it gives me $5,967.81. Okay, and press enter again and it gives me the third answer, $5,550.06. So only show the working out when you have to, like on a SAC or on an exam, or else you can just do it on your calculator like that. So let me just write these in, 5,967.81, and then V of 3 equals 5,550.06. Any questions how I got those? Okay, part B, determine when the value of the investment will first be less than $5,000. So again, I'm just going to use a calculator here. We want to know when it's less than 5,000. So I'm going to go 5,000. Let me make it equal to $5,000. Equals 0.93 times, I'm not going to put V of n, I'm just going to put n in there because it's easy for the calculator to solve. Solve for n. Okay, you don't need to do it like this. You could just do 5,000 divided by 0.93 and it'll give you the answer. It's up to you. So when you do it, you end up getting oh no, that's not going to work. No, that's not going to work. No, I take that back. I'm going to do it the old way. Just going to do it the old way. We're just going to keep pressing enter on our calculator. So we have 550.06 times 0.93. That's 4. V4 equals 5. Come on. $5,161.56. That's still too high. V of 5 equals 4,800.25. That is below. So how long does it take? It takes 5 years to be below $5,000. Any questions on that one? Okay, I'll let you guys copy that down. All right, let's move on. Part C. Yep, part C. Okay, this is the last one that we're doing today. And part C says, write down the recurrence relation if the furniture was initially valued as $7,500. There's our V of 0. It's depreciating. reducing balance of 8.4% per annum. Okay, so let's get our R. We'll do our R on this side again. Actually, I'll do it on the left side this time. So paid $7,500, it's worth 100%. It's depreciating, so minus by 8.4%. Okay, so we have to work that out. 100 minus 8.4 will give us 91.6. So every year it's only worth 91.6. Divide this by 100, we get 0.916. There's our decimal. Any questions there? Okay, finishing off or writing our recurrence relation, V of 0 equals $7,500. V of n plus 1 equals 0.916 times my V of n. Okay, any questions? All right, let me just clear this.